Hello and welcome to the web series ZeroPM Pieces. In the ZeroPM Pieces, the researchers in the project will tell you about one piece of the ZeroPM puzzle that they're working on. So without further ado, here comes a ZeroPM piece.
Hi everyone, and thanks for watching this presentation. My name is Luc Miaz. I'm a PhD student at Stockholm University. I will talk today about my work related to PFAS definitions. I will start with some backgrounds about what PFAS are. So, PFAS stands for pair on polyfluoroalkyl substances. It is a group of compounds that have diverse structures and properties. They are widely used, for example, in the form of Teflon in cooking pans. Their discovery was made in relation to the development of the atomic bomb in the late 1930s and served the purpose of withholding the highly corrosive uranium hexafluoride. After the war, production extended from military purpose to widespread commercial applications. PFOA and PFAS are the most well-known members of this group. Their structure is shown on the right here with the fully fluorinated carbon chains. PFOA and PFAS are widespread in the environment and in the global population. Here are two maps of global water contamination by PFOA in the last 2 decades, showing PFOA is detected in the oceans, even away from direct contamination sources, and the same is true for PFAS. PFOA and PFAS are known to have adverse environmental and health effects, even at low blood concentration. Production of PFOA and PFAS is now restricted, and this has sparked the development and use of alternatives, both with organofluorine and without fluorine. For example, some alternative compounds have shorter perfluorinated chains, or they have their perfluorinated chain cut in half by an ether group. However, we know too little of the effect of these alternatives on the environment and on human health. Only a few number of compounds can be targeted in analysis, but we know through mass balance analysis that some fluorinated compounds are not accounted for, so we don't have a full picture of the occurrence of these alternatives in the environment. So we've seen that PFAS are substances with diverse structures and properties, and they are widely used. The common properties of all PFAS is the presence of perfluoromethyl and perfluoromethylene that make these compounds persistent because of the strength of the carbon-fluor bonds. New alternatives are used with fluorinated carbon, and these substances have more diverse structures. But are they all like PFAS and PFOA? That's a difficult question to answer for all potential PFAS, and that may be restrictive too, because we also want to spot compounds that will pose lower threat on their own but are still persistent. So the underlying question is, how do we define what a PFAS is? Does the presence of one CF2 or one CF3 makes a compound a PFAS? Or should PFAS be defined with a minimal ratio of fluorine or with more complex structures, for example with a longer fluorinated chain? We'll look at some definitions and at how many compounds these definitions match, as well as how they compare to each other. I'll briefly mention key aspects of the method used for what will follow. So I assembled a database of over 17 million unique organofluorine compounds from PubChem database. PubChem is an online database of chemical molecules that receives data from hundreds of contributors, such as chemical vendors, governmental and research institutions. There are more fluorinated compounds on PubChem, but they sometimes contain multiple compounds that are ionically bonded, or cells that are already present in some form in the database. So I regroup all these forms into one, what I call unique compounds. On PubChem they are also unique in some form, but here they are smaller in size in some sense. I use PFAS definitions from the PFAS tree developed by Emma Szymanski, who is also part of the ZeroPM project. And I added some lists using smarts and RDKit, Python, C++ based cheminformatic tool. Let's start with the broadest definition of PFAS. that is at least one fully fluorinated carbon not attached to another halogen or to a hydrogen. This would match both monomer and polymers, but I will focus only on monomers here. So this corresponds to the latest OECD, to the OECD definition of PFAS. The ratio behind this criteria is that the carbon fluor bond present in PFAS give them high persistent, and that high persistence implies increased contamination if the compound is released continually, as it would probably be in most cases. It implies also a higher probability of adverse effect and mixtures effect that can be discovered late after the contamination already occurred, and it would then be impossible to remove the contaminant globally. If we assume this definition for PFAS, we can identify over 6.5 million compounds on PubChem that would be PFAS, that correspond to 5.5 million compounds if we regroup compounds of similar form, as I explained before. Among the compounds that match this one CF2, CF3 definition, there are well-studied compounds such as P4 and PFOS and hexane sulfonate. There are alternatives such as PFBA and GenX, as well as degradation products. With this definition, some pharmaceuticals and pesticides are also PFAS, but a very large number of compounds are unknown, are of unknown status and use, with many that might be compounds that were included in patents or synthesized just once. So it is difficult to know which compounds have a potential to be used and spread in the environment. When we look into more details at the decomposition of the OECD list in terms of number of CF2 or CF3, we see that most of the compounds have less than 2 CF2 or CF3 in total in these bars. Actually, 85% of the compounds have isolated CF3 moiety. So the graph on the right here shows the number of unique compounds matched by the OECD definition by the total number of CF3 and CF2. So we have the total number of CF2 and CF3 moieties here, and here the number of compounds that it matches. So this is in terms of million. And so for more than 3 moieties in total, we don't see a bar anymore. So here's the same graph as before, but on the log scale. We see that the number of compounds still mostly decreases with the total number of CF2, CF3. From the millions of compounds with a single isolated CF2 or CF3, we get to about a few thousand or less with more than 8 moieties up to 20. And if we count all compounds with more than 20 CF2 or CF3, we get to about 1,000 in total. So this bar represents that number. So the dominance of single isolated CF3 and CF2 in the OECD list might mean that it matches many pharmaceuticals and pesticides. The graph on the right shows the decomposition by total number of CF2 and CF3, and 2 lists that regroup fluorinated pesticides and fluorinated pharmaceuticals here. So we see that all the compounds have less than 10 moieties, and most have 1 or 2. Though the lists are quite small, this suggests that part of the compounds with low total number of CF2 and CF3 that are matched by the OECD definition might be from pharmaceuticals or pesticides pattern. Now let's look at the second definition. This is a more restrictive set of definitions that come from the US Environmental Protection Agency and its Office for Pollution Prevention and Toxics, OPPT. The office set a definition in 2021 that sets PFAS to be compounds that have at least 2 carbon partially fluorinated with no hydrogen bond, as shown on the picture on the left. So this definition, this substructure. This captures about 200,000 unique compounds. In 2023, the same office updated its definition to include 2 more substructures, these 2, in addition to this one. And this new definition adds about 64,000 compounds to the previous definition. In comparison to the OECD list, Hamel et al. Found that only 5 pharmaceuticals in use between 1954 and 2021 were matched by the OPPT 2021 definition in comparison to more than 100 pharmaceuticals that were matched by the OECD definition. This plot now shows the proportion of compounds in the list on the x-axis, matched by one of the three definitions that we've seen so far. The number of compounds matched by the OPPT definition is one order of magnitude lower than the OECD definition. So the blue bars are small for the OECD list here. When we remove single isolated CF2 or single isolated CF3, or both OPPT lists match already more than 20% of the remaining compounds, showing that the removal, it shows the removal of single isolated CF3 and CF2 by the substructure criteria of the OPPT. The OPPT lists match most of the lists called here PFAS Kluge, Chemi and Alternative DB, which are lists containing PFAS in use in specific sectors. And the last one, Rich DB, contains compounds registered in the European Union and having at least one CF2. I will come back to this list later on. Now the third and less substructure-based definition I will talk about is the CompTox DSSTox definition. It is based on a paper by Gaines et al. And is a mixture of short substructure match and a threshold of fluorine ratio. The substructure are shown here on the slide. The ratio of over 30% fluorine also restricts the number of compounds matched by the definition. About 12,000 unique compounds match this definition. The list is again 1 degree of magnitude smaller than the OPPT list. So when we compare to the definition to the same list as before, here are the list to which both CompTox and OECD are compared. And we see that it captures a very small proportion of the OECD list here, even when we remove single isolated CF3s. However, the DSSTox definition matches most of the list focused on uses, so these three, and many of the rich DB. Let's look at this in more details. So going back to these definitions, to these lists, and what they contain. The REACH database contains chemicals registered in Europe that are used at least in some quantities. It is based on the C submitted to ECHA and contains about 500 unique compounds that have a CF2. The Kluge's use list is based on a research article that looked at PFAS used in many sectors. The list contains about 1,000 unique compounds. We see that most compounds in Kluge's list are captured by the DSSTox definition, but that half of the REACH list is not in it. Here we see the three structural definitions discussed before. The OECD definition is the broadest, so it captures most of the compounds in other lists. The OPPT 2023 definition is more restrictive. It excludes the single isolated CF2 and CF3 that make most of the OECD list. Finally, the DSSTox definition is even more targeted and it captures similar high proportion of PFAS in a list that focus on uses. These three here. These are the three lists on the right. So this here, the PFAS Kluge, based on the research paper. Chemi PFAS is a list of compounds in use from the Swedish Chemical Agency, and Alternative DB contains a list of PFAS in use assembled in the ZeroPM project that are notably in the PFAS restriction proposal. Both the OPPT and the DSSTox capture less of the REACH database than the OECD does. This is possibly because these compounds are pharmaceuticals or pesticides with isolated CF2. So in summary, we have generic substructure-based definitions that can be applied on any compound for which we have a structure. We have the broad definition of the OECD that requires only compounds to have CF2 or CF3 to be a PFAS. This definition captures more than 5 million compounds. It tackles the issue of persistence, but it is largely made of compounds with single isolated CF3s. Then we have the OPPT definitions that use more restrictive substructures, which also exclude single isolated CF3s, but is still relatively broad. For example, it can still capture branch fluorinated carbons. From 5 million compounds, we go down to 250,000 compounds with this from the OECD to the OPPT lists. The CompTox DSSTox definition is even more restricting, having substructure matching and a minimal fluorine ratio. These compounds are closer in nature to PFOA and PFOS. There are about 12,000 of them. Then if we restrict PFAS to compounds in use, even taking a broad definition of having CF2, we get about 1,000 unique compounds for which a use has been identified. Finally, restricting even more to compounds that are in use in at least some quantities in Europe, we get about 500 compounds. So overall, we have different PFAS definitions that can spot compounds that might be a risk in the future if they start to be used, and if they are already used, of course. The risk also taking into account bioaccumulation is probably higher in the DSSTox and OPPT definitions, but the compounds matching the OECD definitions are also of concern because of their potential persistence. And with this, I thank you for listening.
ZeroPM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.